All right. For those of you who are just joining us, my name is Mallory Mazzarella. I'm Associate Director of Admission here at St. Edward's University. We're excited to have you here today to learn a little bit more about our computer science programs, and you'll hear from two of our faculty members to give you a little bit more insight into what that experience will be like. Just to give you a basic overview, this Zoom is in a webinar format, so you will not be able to take yourself off mute or turn your cameras on. We won't be able to see you or hear you, but we do really encourage you to interact with us throughout the presentation if you can. We have a Q&A feature at the bottom, and so you can submit a question either anonymously or with your name attached throughout the presentation, and then we'll take some time to do Q&A after the presentation is over. So anything that you submit, we'll hang on to your question and we'll discuss them live and give you an answer. And then if you have any questions about the admission process or anything else like that for me, feel free to type those in as well, and I may be typing responses back to you as we go. So with that out of the way, I will go ahead and turn things over to our faculty members to get us started for the presentation.
Well, hello, everybody. My name's Laura Baker. I'm a professor here at St. Edward's in the Department of Computer Science. So welcome to the webinar. We're happy to have you all here. I know we can't see you, but welcome, welcome. So we're happy to talk. I'm here with my colleague, Dr. Shebaro. He's an associate professor with the department, and he's been with the department 7 years, and he teaches lots of really great classes. So we're happy to be here and happy to talk to y'all a little bit about the program and some of the things that hopefully y'all might have some questions about. I know there's Q&A at the end, so we're happy to talk to y'all about that. So we're going to go ahead and talk a little bit. So one of the things we wanted to talk to y'all about is, why are you possibly thinking about computer science? And this is sort of our thought process on it. Obviously, as we all know, there's lots of positions available in computer science, but it is a challenging degree. It's certainly not a trivial thing to get through. So we really want y'all to do well. We want to challenge you. We want you to learn things. Probably, and Dr. Shebaro will probably talk about this a little bit, one of the most important things is probably learning how to learn new things, because there are new things all the time. So one of the challenges is just being able to learn and understand that, oh, there's a new thing coming in. I might need to learn that. I might need that for my job or to move up in the company to where I might work. So we want to be able to challenge you and teach you to learn. And the other thing we think is really important is you have to be good at thinking and solving problems, which may be a little bit, we don't really care whether you're good or bad at using a computer. This is more about you thinking about problems and being able to design solutions. So if you're good at puzzles, you like doing analytical type things, this is a great career. So it's a lot about that sort of thing. And of course, you guys probably all know this, and parents, you as well. Everywhere has computer science people. There's lots of software developers in every nook and cranny of the business world. So quite a wide range of opportunities for all the students who get through computer science. Good. So I think one of the things that is always a question that lots of students have, and possibly parents have the same question, the main thing you have to be fairly good at is software development. I mean, the focus of computer science is software development. That's not to say you're going to be a developer, but you certainly have to have some ideas about how development works, how things are arranged, what a design is for a system, how to put the components together. And then there's also things like testing software, gathering requirements, which is #1 problem for most people, because you talk to clients and they're like, oh, I want this and this and this. And then they turn around and, 3 weeks later, oh no, we really also need these other things. And so part of this is a communication job. So there's jobs in just discussing with clients their needs and how they can be met. So there's lots of skills that require you to interact with people, even though maybe most of us don't think that's one of the skills you need. It really, really is. Your communication skills have to be good to be successful. And honestly, it's one of the things that most people who hire in computer science like you to be good at is communication, which, you know, of course, they always think if you can get through the degree, you're good enough to learn whatever they might want you to learn or perform whatever tasks they need you to do in software development or computing. But being a good communicator is like a number one, we call those a soft skill, a number one skill that is so important that it's crazy important. So we try to get you all to be good at that. Design is always fun in software too, thinking of ways to solve problems and unique ways and interesting ways, or just maybe the best way. So we're trying to learn to do lots of these things in computer science, and we have a whole set of courses we think that sort of add to your ideas about how to learn how to do this kind of thing. Go ahead, Dr. Shebaro, we'll go to the next one. So an interesting thing, and hopefully you guys are probably mostly aware of this. So software developers, you know, the job market is just on the increase, and I think it's probably stronger than ever right now, and I think it's going to sustain this strength and go bigger and bigger. So we have a slide on what the latest Bureau of Statistics is on jobs. So this is the 2019 median pay, and that was updated as of September 20th of this year. So this is kind of out of the United States government's surveys of different jobs in computer science. So this particular chart I think is very interesting because it gives you an idea of what level of education is required for some of these jobs. And almost every one of them is, as you can see, is a bachelor's degree, right? So the only one that probably requires a master's degree or does is being a research scientist in computer science, because you have to spend a lot of time learning how to do research in computer science and how to build software and how to think about new ways to do that. But you can see the level of salary is on the rise. It has been on the rise for the last several years, and I think it actually is going higher and higher as we move on. So it's a good career, but it's also not easy to get through this degree. So there's lots of great jobs. There's lots of different sort of categories or niches of job titles that people think about. And with a bachelor's degree in computer science, any of these jobs are available, and you are qualified to start at possibly entry level, and depending on if you've done an internship or done some kind of part-time work while you're at school, you can always start at a higher level than some of these pay. These are probably the average pay. I don't think these are starting salaries, but they get there pretty quickly. I think we have lots of success stories here at St. Ed's with lots of our students. So this just gives y'all a little bit of an idea of the different job titles you might see or hear about or want to know about. And I don't want to go through them all, but they're pretty good. And you guys can all see, obviously, this slide. We're just trying to get you to think of different things that you can do with such a degree as computer science. So a full stack web developer, the idea of a stack is a set of software that's installed or used by a particular system, and knowing the various components of that stack or group of software that makes a web-based system work is what a full stack web developer is. And that the requirements and the knowledge involved in that is just in a fairly rolling over state. There's some stableness there, and then it changes the next thing you know. So there's lots of really interesting and cool stuff going on web development, and same thing with mobile application development. And of course, we teach classes that have to do with both of these things. And then software engineering is a standard class. We teach you how to be a software engineer on an industry, the different tools that are being used, things like that. So that's a really great class. And A system architect is someone who designs a system and, sort of might hand it over to a project manager or somebody to take care of building it. But the architect is kind of the designer. So there's a little bit of art involved in that, thinking about what is a good design here and a good way to solve a lot of different problems. And those are fairly good jobs. And then network administrator, of course, everybody's got a network now. And there's lots of cloud computing and everybody's requiring cloud services. So that's a really important position. So I think Dr. Shebaro is going to talk a little bit about some internships and opportunities you'll have at St. Ed's that we have some partnerships with. So Dr. Shebaro.
Thank you, Dr. Baker. It's my pleasure to be here to talk to you all about computer science at St. Edward's. So I want to start off by talking about what are internship opportunities available for students in computer science and what they are available to students even this summer. So starting off, there's an institute on campus called the Institute for Interdisciplinary Science, also known as the I4 Institute. It's one of the institutes on campus that is offering opportunities for students, and it's trying to build capacity in students to increase their readiness for the workforce. And one of the student initiatives that the I4 Institute has is supporting students for paid internships over the summer. This is a list of companies that the I4 Institute has been working with or partnered with. We have VMware, Capsch, Neon, TCEQ, and Macromaltic. Those are opportunities available for all students in natural sciences, really, and of course, computer science students are included. Again, those are paid summer internships, and they are great opportunities for students to take advantage of. And another opportunity by the I4 Institute is micro-credentialing. And let me take a moment to explain this. These are micro-credentials or certificates that students take from courses, probably online, that are to teach them skills that they will use them later on in their, that they will probably need for their workforce. Now, those awards are up to $2,000. So the Institute will pay for the cost of these certificates that you might be looking into. Let me give you an example of certificates. So for example, in my case, I teach the mobile programming course where I teach how to make apps on the iPhones, on the iPads, and we also touch a little bit on how to make apps on the Apple Watch. Some students want to go further, perhaps, right? They want to go, well, I need to learn how to make apps on the Apple TV or on the Mac itself, Mac OS itself, or I need to really be very professional in making apps for the watch, for the Apple Watch, and so on. While we don't go that far in the course, but we focus on the iPhone and iPad apps, so students can take advantage of these micro-credentialing opportunities and apply for courses to take certificates in them, and the I4 Institute will cover those costs. Taking into consideration that those certificates or the courses that students apply for must not be offered at St. Edward's, of course. And examples of online courses that our students have looked into or taken are courses from Rice, Cambridge, UT, and you guys name it, there's plenty out there, especially for computer science. And the good news is there's no deadline for these applications that are accepted throughout the year. And they are accepted from all levels of students, from freshmen all the way to senior. So that's great when you if you join St. Edward's to take a look at that. By the way, if you're curious to know more about this, the website is stedwards.edu/I4. So www.stedwards.edu/I4. We, at the computer science department, we offer 3 computer science degrees. We have a Bachelor of Science in Computer Science, we have a Bachelor of Arts in Computer Science, and we have a Bachelor of Arts in Computer Information Systems, CIS. All 3 degrees require a set of courses that students will need to take. In the next slide, me and Dr. Baker will go over some of the courses that are offered and we teach at in our department?
Yeah, so all three degrees require sort of these general computer science courses that are fairly typical in, I would say, most computer science curricula at most universities that have computer science programs. So the first one, the Introduction to Algorithmic Thinking, that's not the first course. There's obviously a Computing Concepts 1 and 2 class. We teach those, and we didn't put those down, but those are prerequisites, of course, for some of these others. But they are taught in Python and Java. So those are the two, probably, if you were going to pick a language, probably the two main languages we use quite a bit in computer science. That's not to say it won't change in the future. I think we've changed languages no less than probably 5 or 6 times since I've been at St. Ed. So there's quite a long list of programming development languages that we've used, and those are the ones we're using right now. So we like you to think, right? So in the beginning, I talked a lot about teaching you to think and learn correctly about how programs are designed and how to think about things in a way that it's possible lots of us aren't thinking the way maybe we want to. So we're trying to get us on that same path of thinking about solving problems. Web programming, we do stack development on web programming. So where we had earlier, you saw full stack development. Our web programming class is taught using a cloud-based system. Everybody installs all the software, learns how to do a web-based system, how that all works, how to put a little small database in it, just to get the feel for how that all works. And it's quite fun. And it's really helpful for everybody who likes doing that kind of thing. So it's a really interesting course. Of course, there's a standard organization and architecture course that is very standard, because I think the one thing we want to make sure you know is, how do machines work? How are things added? How are they compared? How does information transfer from memory out to disk or off to the internet? How's that all go around? And so part of this is us thinking about how that works. And everybody has to have some basic knowledge of that, because you can't understand why programs work the way they do if you don't have a good understanding of systems and how they interact with low-level components of a machine and higher-level software. So that's always a fun course to learn how things work. I'm always like, isn't this the coolest thing ever? And everybody's always disappointed that I think it's so cool. But so I think that's a great course. And then component-based programming is another course that you're thinking about design and thinking about putting pieces of programs together and testing pieces of programs and programming by contract. So there's lots of details in these courses that help you think properly and design software. So we're trying to think about how software should be developed and how things should be working properly. And then we have, of course, a standard data structures and algorithms course, which all curricula has some course with that title. And that's always here's how standard data is stored in a sort of programmatic view and different ways to manage it and to build components that are based on various interesting ways to handle data and solve problems. So data structures and algorithms is a very standard course. So Dr. Shebaro is going to talk about database and a few of these other courses, and then we'll come back and talk about some more. Dr. Shebaro.
Yes, so moving on to the next course, database theory and applications. This is a course where you learn all about data and how you store data in an organized way, which is in a database format. We look into relational database systems. The nice thing about this course is that we start from the very basics, which is we have a case study, we have an idea of building a system that requires saving data, and we move through all the phases of the requirements, plotting in the business rules, into designing the database, all the way to implementation and testing. It's very important, as you know, to properly store data in systems, whether it's a website and there's data behind it, or it's a mobile app and there's data behind it. This is a very core course for many of the applications that you do in your computer science career. Operating systems and networking is another set of courses in the systems category. Operating system, you'll learn about all the how the operating system functions, from processes to threads to memory management, permanent storage management, and all this stuff. So really cool stuff. Understand how our computers function and the software behind them. Computer networking is also a very important topic in the sense of learning about all the protocols, TCP, IP, each layer, and what does it do, and learning about many architectures and networking. Mobile programming is the one I talked about earlier. We teach iOS programming and how to make apps for the iPhones, iPads, and I said a little bit about the Apple Watch. We teach the using the language Swift, which is a language was made by Apple in 2014, which is that's all the cutting edge. And this language is so dynamic. It's just every year there's more features, as you know, from your phones. You get lots of updates and better phones and augmented reality in phones and stuff like that. We keep this course up to date to always teach the cutting edge stuff and the latest updates about it. Computer security and privacy, I cannot emphasize enough how important computer security is nowadays. We talked about all the threats available in our computer systems, all the defenses, all the mechanisms. We also talk about how to defend. We build software, right? So we need to know how to make our software secure, how to store our data in a secure way, and how to defend against attacks all the time. And so also we learn about privacy mechanisms and how to protect user data from any privacy invasion mechanisms. Software engineering, we touch on that also. You're learning in software engineering pretty much the whole life cycle of a software engineer and how to build the software. Again, from the early stages of having the requirements and designing the whole software all the way to implementation, testing, and what have you. Also, you'll learn a whole bunch in software engineering about the tools that are used, and also we keep ourselves up to date with all the current tools that are used in industry. That's, of course, a very important course that students will go through. Science courses and labs. This is also built into our degrees in computer science. You are required to take 2 sciences, especially for the Bachelor of Science in Computer Science. They're required to take 2 different sciences in a lab. Sciences like chemistry, biology, astronomy, bioinformatics, and others. They're all among the sciences courses, and of course, associated with the lab. Math courses are also some of the math courses required in some of the degrees. Calculus, statistics, discrete math are all courses that also very interesting and into our program. Senior project. So every student in computer science in all three degrees are required to work on a senior project at their senior year, which is pretty much the last fall and spring. It's a 2-semester project where students will work on, I always call it, it's the best project you've ever done, given all what you learn in the courses in your program, and most likely in your first 3 years, and that project is in your 4th year, more or less. So yes, it's an interesting project. Also, you come up with an idea and that you need to solve a problem for. Of course, you will have a faculty mentor working closely with you in order to produce a project that is really nice, presentable, and you can also be using that project sometimes in presenting it or talking about it in your interviews when you apply for jobs. In addition to all of this, there's of course general education requirements that are required in general for all students in natural sciences and on campus, really. So this is a quick overview of our courses that we offer in computer science. There are others, but that should have given you a really good idea of what courses we offer and what courses we teach. It's not just me and Dr. Baker in the department. We have a really good group of faculty and colleagues in our computer science department. Dr. Michael Cart, Dr. Ryan Michaels, Mr. Thomas Moe, and Mrs. Wada. So we are excited, and we are to be working together, and we collaborate really nice together, and we always work together towards the success of our students in the department, and we're always working on ourselves to stay up to date with every technology out there and tools so that we can deliver the best material to our students. With this slide, I want to really excited to look forward to your questions. You might have a lot of questions about our department, so I want to take the opportunity to answer your questions. I want to also add, this is, as you can see in the slide, our emails. If you'd like to reach out to us, please, emails will be the best way to reach out to us, especially nowadays. But we'll be happy to answer any questions you might have. Mallory?
So please feel free to type in your questions via the Q&A. I see we have one already. Is it possible to do a double major with computer science and video game development?
So I'll take that question, and I think Dr. Shebaro is welcome to add some information. I think it's pretty difficult to do a double major, and I'm not sure that's the right idea, because it turns out that computer science, for sure, takes a lot of time and effort and hours. And if you're going to spend time doing extra work, we would prefer you did an internship or had some kind of job working in some kind of related, in industry when you're able. And if you do a double major, you tend to be all about just finishing those credit hours. And I'm not sure it purchases you what you really want, because one or the other should be chosen. And of course, we're in computer science. So of course, we think computer science is a more general major than video game development. And we think the opportunities are probably a lot wider in computer science. But that's not to say video gaming is not a good choice or anything. I just think the opportunities across the board are much higher in computer science, and video gaming is a little bit more of a smaller niche, and it doesn't give you quite as broad a range of courses that are outside of video, that particular thing. So we're not big fans of double majoring, because I'm not sure that's the best way to spend your time. That's not to say people haven't done it, but it's a lot of hours, and I don't know that it gets you probably as much further down the road as you'd want to be. I think it's always okay if you wanted to minor in, I'll say, business, just in case you want to go do an MBA later on. Maybe you're going to be a project manager or some kind of manager at a larger company, and sometimes they require a master's degree. And so my thought would be, if you're going to spend some time doing some extra classes, do a business minor, do some basics that fill in for an MBA, so that when you graduate, those core courses in business apply to MBA programs. You don't have to go back and retake all that lower level stuff that are required to get into an upper level MBA program. So that would be my recommendation. We've had people minor in other things, but it turns out that most people just major in computer science, because it's a challenging set of things, and usually they can find a job and do that, and that's usually a little more satisfying and probably more helpful in the long run. So that's my opinion on that. Dr. Shebaro, I don't know if you want to add to that.
I can just add one more thing, which is, as you, Dr. Baker, said, computer science is a busy major. It will, the curiosity and learning more about everything you learn in class, working on the assignments, busy in the summer, probably doing internships. That's what some of our students do. Will keep you busy. So, but it's a very interesting major, of course, and historically we see that our students are really enjoying the major, but also busy with it at the same time.
So I'm actually curious to ask a little bit of a follow-up question to this, because this is something that on the admissions side, I think we hear a lot about, where students have an interest in video games or an interest in, on the hobby side, and they're looking to see how they can connect that with their work or their studies in college. Do you find that for students who are interested in gaming, computer science offers pathways into that field, kind of as an alternative?
I'll start, Dr. Shebaro. I think it's true that majoring in computer science and having a degree in computer science can get you a job at a gaming development company. I think majoring in video game development does not get you a computer science job elsewhere. So the niche in video game development and those skills that they require is much narrower, and the number of jobs, I mean, that sounds like the funnest job ever, video game developer, but I don't know that the opportunities for positions is that high in that industry. Everybody wants to do it, but there's not as many positions, and I think they don't pay quite as well as you might imagine they would. And I think it's a tighter, very tight job market, to be honest with you. So that's just my opinion. And Dr. Shebaro, I'm sure you might have some other insights into that you might want to share as well.
I can add to say that to design and make a game, it requires a lot of different people and different disciplines, from graphic designers to programmers to computer scientists and game designers. So the fact that if students choose to go through computer science but they have interest in game design and game development, that route is always available for them, right? You get the programming skills, you get how to all the skills needed to build software, and that can get you jobs in that market and in other markets too.
Great, thank you. We have kind of a related question that was submitted, and I think you touched on this a little bit already, but is computer science with a minor more advisable? And I don't think this is specific to game design. I think this is kind of just pairing a minor with the major in general.
I think, again, a minor, if you wanted to have a minor because maybe you came in with extra hours and you have extra room in your degree and you have some burning interest in something else, I think that's great. I don't want a minor to take away from your ability to be successful in computer science and to get internship opportunities and to get experience doing things that you're going to do a lot of, and you want to be good at things. So and some students minor, but a lot of times maybe start a minor and then decide that it's too much. So it depends on the person, but if you have some desire to be in graphic design, that takes a lot of time. But some students do graphic design because they really enjoy it, or they might do art. But you are always challenging your time where you're going to spend it if you have a minor, because the 120 hours is 15 hours a semester for 4 years. That is a full load the whole time you're in school, taking 15 hours. And that's assuming you don't maybe only take 12 one semester, and then you got to pick up 3 more somewhere else. And so this degree tends, and all degrees do, they tend to add up quickly as far as the requirements. So I think if you start a minor and you decide that it's too much, that's fine. I'm not sure, I'm not convinced, I haven't heard that people minoring in something really gets them in the door somewhere. So that's my take, and I feel like I've said that too much probably, so I don't want to detract from you wanting to learn. I think that's awesome. I think this is a tough major time-wise because it's intensive. There's a lot of work to do.
And Dr. Shebaro, did you have anything to add?
I wanted to just probably say that there's a lot of fields in computer science that people can think of and can explore. Some of the things in courses and some of the things are on their own. There's a lot of routes that once you are a computer scientist and you have all the basic and good knowledge out of college, so many routes to go there. I know we have a group of students that like game design, and we have other students who like to go into the mobile programming route, and another would like to go look into artificial intelligence, or look into machine learning, or even look into all the science behind drones and 3D printing and all of this, and all of this requires this basic good core in computer science and in coding, because they're all being used. The other thing I also want to say is lots of applications nowadays, and this is not new at all require a programmer, it requires IT, it requires the use of technology in advancing in many fields, in all fields we can think of. And now more than ever, we've seen through the pandemic how technology stepped up with many other, of course, important cases where and disciplines that jumped up on the table. So it's good to be a computer scientist these days.
Thank you. And one other thing that I'll add to this, just from a more kind of general perspective, from the admissions side, is that this is one of the advantages of studying at a liberal arts school, that you'll have the opportunity kind of baked into your curriculum to explore different subject areas, take classes in different fields, work on some of those soft skills in other areas. And so even if computer science is one of those more demanding majors where you kind of want to focus all of your energy in one place, you're still going to have the opportunity to take things in different areas. And there's quite a bit of flexibility with how you can do that and where you earn those credits. So you can use that sometimes to explore some of those side interests without necessarily making it an official second major or a minor. And I can say that as someone who went to a liberal arts university too. You can kind of, use that exploration to get some of that curiosity satisfied.
Very good.
Oh, sorry, go ahead.
No, I just want to, I'm glad to see questions arriving, but I would really encourage all of you, if you have any questions to ask. There's no question that is silly. There's no question. It's a great opportunity. This is the time to ask questions. I know at this level, probably you're at high school, you have so many questions, and we are here just to encourage you to ask these questions. Any question can help everybody here. So please be encouraged to ask questions.
Great. Thank you for that advice. I would definitely second that. And you remember that you can submit them anonymously too. So if you don't want to attach your name to a question, that's totally fine if that emboldens you to submit something. I see that we have a question here, but based on your experience, which field is your best or most favorite? And I think this question is addressing sort of like areas within computer science that you can specialize. I don't know if you can talk a little bit more about just some of the different subject areas that you can focus on within that major.
Dr. Shebaro, I'll let you go because you teach some of those concepts.
So the good news is most of us as a faculty in the computer science department, we all have different interests in computer science. So it's interesting sometimes when a student comes in and says, hey, I like this and I like that, we can direct them to the right professor that they can discuss more about it. I'm not going to speak about everyone else. I'm going to speak about myself. I have, of course, a lot of interest in computer security and privacy. I've had a lot of work in that area and publications as well. I also been really enjoying working on mobile programming, teaching that course, looking at looking for creative ideas that me and the students work in class, and it's really heartwarming how to see the applications and the project ideas that the students come up with and present in that course. It is interesting how the approach they take in trying to solve a problem. They don't just do a mobile app, for example, for the sake of presenting their skills, but actually they start with a problem. We have a problem we need to solve, and they study what existing solutions we have and what's the problem with these solutions, and they try to come up with a solution that is better than what it exists. So this is a really interesting part that I really enjoy seeing in our students. We do give students a lot of authority in choosing the project type, the projects, the ideas that they want to work on. Of course, we're always close to them and supporting them with all the ideas. So again, going back to the question, I enjoy security. I enjoy playing with malware, looking on how they work, always keeping myself up to date with all the current attacks and learning from them, and how learning from the defenses as well. We also look into all this, something I haven't mentioned in the computer security course is Bitcoins. I know a lot of students heard about Bitcoin. So we tackle this. We look into how the Bitcoin originally is designed and how it functions. We don't talk about how to use it and how to trade money. Not at that. We look at what's happening underneath, all the hashing that's happening underneath, all the data mining all the mining that's happening, and stuff like that. So as a computer scientist, we kind of look into things like that. I just want to say something about me. I know there's a huge group of gamers out there. I want to say that I used to enjoy games and I play games, right? Probably around also high school. At some point when I became a computer scientist, all I can think of when I'm playing a game is how is that implemented and how is that done? So the part of me enjoying the game changed a little bit to like, I'm thinking of, oh, how did that player made that jump? What are the code behind it, or how the, so it's interesting to also think about while you are using computers, using games, using all what you use in IT, to think how these are things happening. So same example I mentioned about Bitcoin, you're kind of like, if people use it or not use it, but still good to know what's happening underneath, how it works, how it functions. So that's some of my interests.
Yeah, well, I would say that I'm probably on the softer side of, I enjoy full stack web development. I like human computer interaction. I like the design of systems, and I like how you think about them. And along with what Dr. Shebaro says, like once you start doing this, you find yourself, oh, I wonder how they've got that set up to make that work. And how's that, I'm always talking to people, don't you care about how that ATM works? Don't you care about how quick the point of sale terminal works at, the grocery store? Aren't you interested in how that all is put together and designed, and how come it's still working? And then when the electricity goes out, what happens? And so you almost can't help yourself, because your mind just almost doesn't ever stop thinking about this. And so I think I'm interested in us understanding how things work and thinking about them. And so I like to teach those kind of courses. And so we all kind of have our niche in the department as to what we tend to favor. And I of course do a lot of the second level computing courses and data structure, those kind of courses. So those are the things I just really enjoy and think they're so fun and interesting, because they teach you to think about how everything's working. And as Dr. Shebaro said, you can't turn it off. It's also interesting that it's just a constant flow of things. So that's just kind of maybe how this works. I'm not sure it works that way for everybody, but the mindset is difficult to get out of, but fun.
That's great. Thank you so much. We don't have any other kind of audience submitted questions at the moment. If anybody has anything, feel free to type it in. But again, something that I hear from prospective students a lot is asking about internship opportunities, and especially what kind of might be available in Austin that students can do while they're studying at St. Edward's. Is there anything in particular that you would highlight, or experiences that your students have had that you want to share?
I'll let Dr. Shebaro go first on this one.
We are really fortunate that our campus is in Austin, and Austin is the tech hub. There's so many big and small and startup companies in here in Austin in tech. And the nice thing about it is that our students find internships and participate in these internships without the need for them to change their residence, for them to change location to where they currently live, because it's all within the city. When I was a student, when I want to take internships, I sometimes had to travel or move to a different city or state to do the internship. While here, most of our students find internships within the city. The other thing I mentioned earlier in the presentation about the I4 Institute student initiatives for paid internships, and those are another opportunities that are available. So for example, this summer, we're looking forward to students who are juniors and seniors who will be returning in the fall of 2021. We're looking forward to support 15 students within the School of Natural Sciences. They're not all going to be 15 computer science students, but talking specifically about computer science, in summer 2019, the I4 Institute supported 4 computer science students. Summer 2020, which was last summer, we supported 6 computer science students. And this year we're looking for more opportunities. So whether they are supported by this institute or whether students find on their own, it's really popular among the students. And the best part about it really is that students connect with each other and students go do an internship. And some of these students already make it as a full-time job in these companies. And then when somebody from St. Edward's apply, they kind of know them, they know the connection, and that helps a lot. So I really find it very feasible for our students to find internships within the area.
Yeah, I would agree with that. I think that's the number one question, but we always have to, so I always want to say, like, until you're probably going into your junior year, you're probably not prepared to do terribly lots of work. Now, that's not to say you couldn't work somewhere and do some IT support or something like that. And of course, St. Ed's, our campus, we have an IT department, and we hire a lot of our students to get some experience, because I think getting your first small experience is probably one of the toughest things. And once you have that, people are more willing to hire you. So we encourage students to work at St. Ed's before they're juniors, if they're looking for that, and to talk to other students, because once one student, and it's funny how this goes, a student might work for a company like Accenture or CDK Global, and one or more of those students who do that as an intern end up probably working there full time. And then they call us up and go, hey, we're looking for some more interns for the summer. Do you have anybody? So we can forward some students over that way. So there's a lot of networking that goes on internally and with our alums who have graduated and who are out there. And I think that's a really successful endeavor that's hard to quantify, because it just happens without us working hard at it. So our students sort of want to come back and call us up and say, hey, I have an opening. Do you know anybody that would be good for us to hire? And of course, we're like, oh yeah, we've got plenty of people. And so I think there's a lot of networking at a place like St. Ed's that's really helpful. And so I think that's a great opportunity. And then I think just grinding the pavement and the web and just looking for just job opportunities, the VA, the IRS, there's a lot of government places also in Austin that hire student workers. And so I think there's plenty of opportunities. It's just a matter of us trying to guide you, to find those things.
All right, thank you so much. I think we had a student I was typing back and forth with that may have one more question. In the meantime, is there anything kind of as we prepare to wrap up, anything final that you would share with students, advice as they're entering college or trying to decide on their majors for sure?
I'll start, because I'm never one to be shy about this. I think it's important, even, like if you want to start in computer science, and if it turns out it's not something you want to do, I think everybody should think about, I'm going to get a degree and complete it, because the time you're in school will go by quickly, and the time goes by whether you complete your degree or not. So I'm always like, I want you to be in computer science, and we want to make it as successful as possible, but we also think that a degree is important. Your earning power is a lot higher over your lifetime, and the time you spend at college when you're just out of school, and I was in the same category as many of you are right now, you kind of don't really understand the importance of going to college. You're just like, everybody goes to college, okay, I'm going to go to college, and you don't really have the thought processes to think this is a really critical thing to complete. And I think it's one of the milestones that everybody should be very fortuitous about, and stick with it no matter where you end up going to school. Don't let anyone sidetrack you from finishing. You should work hard at this. It's worth it. It will make you very successful in the long run. And the short term may not look as successful as the long term will become. So don't lose sight of that, even though it feels scary or different or you're unsure. Do something, because if you don't, you will regret it later when you're older. We have plenty of those examples. So we want to try to, I just want to say, just from that perspective, get a degree. And, if it's at St. Ed's, we'd love to have you. And if it's at another place, get a degree.
I'd like to add one thing about this. I cannot agree more with you, Dr. Baker, about this. And I'd like to say also that the college experience is unbelievable, especially at St. Edward's. There's a lot of things going on for students. It's a really feels like one big family, and our faculty, whether in computer science or anywhere really on campus, are very approachable. You will be and they're also available for students. So you will always be able to email a professor and get a response. You'll always be able to walk in and find their offices and talk to the faculty directly. You need help in a homework, you need help in the lab, you need help in some concept you didn't get well in the lecture. There's always all these direct contact with faculty, and our faculty knows students also by heart. If a student is missing, not in class, I hope that doesn't scare you, but if a student is missing, not in class, we will notice. Sometimes if we notice that happening often, so we email the student, we follow up with our students. So it's a really good, amazing environment and very encouraging, whether it's coming from faculty to students or students among themselves, and with all the various offices on campus. It's really a good experience to be a student there.
Well, thank you so much for taking this time to share information with our students, and thank you attendees for typing in questions and submitting things. If there is more that you want to know, or if there are ways that the Office of Admission can be helpful to you as you're working through this process, please feel free to reach out to us. You should be able to find our contact information on the website, and I know our presenters shared theirs as well. But thank you so much for your time, and we hope you have a wonderful weekend.
Good seeing everybody. Thank you all.
Thank you.
Thank you all. Good luck.